This is number 27 on worksheet 17.2b for Algebra 2. This is going way back to first semester concept 5, where we have the system of three equations, and we have to solve for the x, y, and z solution. And usually what I showed is we would number these equations 1, 2, and 3 just to keep track of which ones we're using. And the idea is that you're going to choose any pair here, and you're going to try to get rid of either x's, y's, or z's. Now let's say if I go with 1 and 3, and I'm choosing 1 and 3 because I'm noticing that I have 1x and 1x. Those are easy to make cancel out. Now equations 1 and 3 I'm going to put here. Equation 1 I'm going to keep the same. I'm going to keep that as x minus 3y plus z equals 22. Equation 3 though, I'm going to multiply by negative 1. Because now it's going to make this x a negative, which I want to happen because that's going to cancel out with the positive 1x. This is now negative y minus 3z equals negative 24. Again, those x's cancel. So now when I combine these equations, I get negative 4y minus 2z equals positive 2. Now that's one equation. I want to now get another equation that has both y and z. So remember that I chose equations 1 and 3. So I'm going to choose any different pair now to get rid of the x's. And it's a good idea to start with, let's go ahead and use the equation 1 again. But now let's go with pairing it up here with number 2. And now for numbers 1 and 2, equation 1, I'm going to multiply this equation by negative 2. So this is all getting multiplied by negative 2. So it gives me negative 2x plus 6y minus 2z equals negative 44. Now equation 2 I'm going to keep the same because positive 2x now will cancel with that negative 2x. Minus 2y minus z equals negative 9. Now when I combine, I get 4y minus 3z equals negative 53. Yeah. Now I've got two equations with just y's and z's, and the nice thing is that the y's cancel out right away. So now I'm going to combine these together. I'm going to write the negative 4y minus 2z equals 2. Positive 4y minus 3z equals negative 53. Combine the y's cancel, I get negative 5z equals, and I feel like there's a mistake in here somewhere. Oh, this should be a negative 2, because when I combine these, 22 minus 24, I got a negative 2. So that's now negative 55 when I combine those. I divide by negative 5 and I get positive 11 for my z value. So back to the original one, there's positive 11 for the z. Now to get the y, I can take this positive 11 and I can plug it into either one of these equations, doesn't matter which one. It's right here, so let's go ahead and just go 4y minus 3 times 11 equals negative 53. 4y minus 33 equals negative 53. Add both sides, you get negative 20. Y equals negative 5. And now that I've got the y's and z's, I got y for negative 5, z for 11. Now I can go to either of these, any of these original equations, and just plug these into both y and z. And this one looks like it's going to be easiest. So I'm going to start with x plus, instead of y, negative 5 plus 3 times z, which is 11, equals 24. X minus 5 plus 33 equals 24. X plus 28 equals 24. Subtract 28 from both sides, and you should end up with negative 4. So my final answer is negative 4, negative 5, positive 11.